Before heading to the video, if you haven't subscribed the channel, do subscribe it and don't forget to click the bell icon for the latest update notification. If you like the video, do like, comment and share. Stay tuned with learnbay.co. Happy learning!
Today we are going to look into a new technique uh, that will be fairly common to use, and let me explain how this thing works and what is the utilization and how to use it in a best possible way. And let me open 1 second. Okay, so let's start the idea to linear regression. Okay. Regression refers to correlation between dependent and independent variables. So, do you remember what was correlation? Any of you? What is correlation?
If there is any relation between the samples or list or something.
Okay, all right, very good. Okay, so as I might have mentioned last time, if you take equation of line, and I was trying to explain you what everything or how you refer these things. So this is referred as output or labels. What is X called?
Input.
Very good. Or features. And M and C are called? What about M and C? Parameters. You should remember this. This is important. Okay. Okay, all right. So fundamentally what we are saying is regression kind of relates or kind of refers to the correlation between dependent and independent variable. So if we take like equation of line, actually this figure will make things much better. Okay. Simple linear regression is a basically statistical method that allows us to summarize and study relationship between two real variables. Although you could have multivariate regression as well, which could be about multiple variables. In very simple words, if you have to understand, if this is X and this is Y, then the whole plan is that to come up with the equation, a linear equation, mind you, which is the best representative of the given data. Now you can tell me the correlation is highly positive, but it is not exactly one, is it? People?
Yes.
Yeah. So if correlation is not exactly one, what is the implication here? So okay, if the correlation was exactly one, how all the points would have looked? They would have literally looked like, or if I were to draw them in a straight line.
Moderate.
This is not moderate. We are talking about if correlation or Pearson correlation is one, They will literally look like they are in a straight line, all the points. Okay, but this is, as you might have said, it is my moderate, or in my view, actually, it is a pretty strong correlation, positive correlation. It's not even a moderate one. Okay. But the what if, okay, correlation is high, we understand this, but what if I ask you, sorry, that you find y is equal to mx plus c, or a more generalized formula is y is equal to theta 1x plus theta naught. So how would you find these two values? Okay, now remember, because you will be given the data at some point. Okay, now it's gonna be a structured supervised data. Okay, structured supervised data means x and y are given, they are provided by the data points. This is how we can plot them, of course. And let's say it is 1.2, and this is, let's say, something 1.3, and so on, so on, so on. So what is the unknown part in the equation? Theta 1 and theta naught. This is what you have to find, right? So how you will go about finding them? So that's what's gonna be basically covered today. So don't worry. Okay. So let's see example. Okay. So case in point is a housing price prediction problem. Okay. The idea is that we are given training data with sample inputs. Okay. So we have input X, input feature is X. So, okay, what would be the correlation of square footage in size or house area to the price? How would it be related, or how would it be connected? Just by general knowledge that you might have.
As the size increases, price also increases.
Very nice. Basically, you can imagine it as a positive correlation. Am I right?
Yes.
Now, my question is that can you approximate that somehow if I were to construct equation utilizing this x? So some theta 1x plus some theta naught, that's the intercept, equal to y. How will you find theta 1 and theta naught?
Maybe by mean.
Interpolation.
Sorry.
Mean. Maybe by mean of
Okay. So just by taking these 4 points, can you figure it out? Can you give me an equation, what it would be?
Yeah, actually with two equations we can get theta 1 and theta naught, right?
Okay, that assumption might have been correct in deterministic mathematics, but you are not in deterministic world anymore. Remember why we are not in deterministic world? Okay, so what you said makes sense when we are in a school, right? So let's say
We
there, like these two, you can always draw a straight point or straight line. Let me draw a straight line between them. And basically you can extend this towards infinity, both of the either of the infinity. Okay, but the problem is that we are going to deal very soon is the points first of all not lie on a point exactly anyways. See the problem? Now they are positively correlated. I agree with this. So what you have to do is you have to find a best fit line which will kind of be the representative of all the points, or most of the points at least. Now you see the problem, what you cannot do that switching thing that you might have done it in school. Means you would try to construct two equations, then replace the variables, right? Substitution. You can't do here because you can see most of the points are not actually falling on a line. So how to know which one is the best line?
Um,
Which one is the
Depending upon
closest
the
line?
error.
Very good. Depending upon error. Now, how to calculate error? Miss, this has been covered already, but how to calculate error?
Yeah, as we discussed, that root mean square error
Very good. Root mean
or
square error or mean square
model.
error. Okay, what I want you to do is first start with basics. Let's say, let's write it out. Write out few things. So okay. So right now we are doing regression. Okay, and in regression we are targeting linear regression only. Linear means in mathematics, if someone says linear, what does it means?
Straight line.
Yes, very good. Straight line or first degree. The highest power is first degree. Basically, you cannot have a higher power in the equation. So it is going to be a straight line. So we can write it like y is equal to theta 1 x plus theta naught. Okay. Or if you want to generalize it, theta I dot xi, where x0 is 1. Please write it out.
Sorry, x0 is equal to 1, right?
Okay. So basically you understand that these two are same equations. It's just more of a generalized form. So if you were to replace, let's say theta n is 1 only, okay? So what would the equation look like? Agreed? This is what it would look like. Come on, guys.
Yeah.
Now x0 is 1, so the equation will be looking as theta 0. So thus the final equation is nothing but. Similarly, you can construct something called polyvariate. Polyvariate means multiple variables or features. It simply means you have lot of x. So again, you can take the generalized form. And maybe put a theta naught at the end. And again, if you want to represent it, it is same 0 till n. Make sense? Okay, everyone is clear till this point because we have to get into some maths right now.
Yeah.
Okay, very good. So let's initialize by a hypothesis of theta, because theta is the variable, guys, not x. So let's say our variable happens to be, our hypothesis. So initial mathematical assumption is this is a linear equation. So we say it is theta I xi, okay, where again same idea. Okay, so now this is theta as theta, because again remember theta is the variable, x is known to us. So theta have to be determined. Theta is in machine learning terms we like to call it as parameters. or coefficients. Okay. So how would it work now? So again, the idea is very simple. You have to have some kind of error. Now, which error we should take or consider? Error is basically your y actual or the actual output minus y predicted. Okay, so this y actual comes from where? Data. And this will be made available to us by the hypothesis that you have selected. So the diagram or the representation might look like this. Okay, one thing I have to explain you, and I will explain you right away because this is important. Okay. Now, whenever you start with your data, the way we kind of do it in machine learning, that we have to split the data into training and testing. Okay. So let me explain what these two are good for. So let's say you have data. Let's say in that data you have 100 rows. Okay. Now remember, this split is along the rows, not along the columns. Now, idea is for training, you take certain percentage of data, and for testing, certain percentage of data is taken. Okay. All right. Now it might seem counterintuitive, but it is very important. Okay. So why we are splitting the data? This is called splitting the data. Into train and test sets. Why are we doing this? Why are we splitting the data into train and test sets?
As this is undeterministic, we need to test how far it is correct.
Very good. Basically, you are very correct. Let me give you a very good example. So, any of you have ever bought a house?
Yes.
Okay. Ever talked to some kind of property dealer?
Yes.
Okay. So let's say in India, because let's say India is a very booming economy, so we have like a lot of construction going around in at least all in major cities. So in all the major cities, you have these property dealers and developers and who not. Okay. So let's say there is a phone. Okay. And at the end of it, there is a dealer. Okay, property dealer. So there is a new development going on. Let's say it's a residential development. Like a residential development happening. So you want to buy a house. So there are different kind of houses. And this dealer has been dealing in property, let's say for 10 years. So the idea is he pretty much knows how to sell property in and out. So you can say he has learned this business very well. Okay. So you call you as a person, let's say one person, you call up the dealer and dealer talks to you. Okay. And basically you ask questions and dealer will answer. And accordingly you figure out this person has learned the business because they can answer the questions correctly. Now one day what happens is the dealer has to go out and he has a 10-year-old son. Now the problem is the son doesn't know anything about this business, okay? But dealer has to go out for 1 hour, and basically he says his 10-year-old son to use the brochure for reference, okay? And just answer the whatever whoever is calling about the property. Just answer them, and if they are interested, again, of course, they will call back, and then the dealer can deal with the person. Now you call this son, basically you call expecting the dealer, but you get the son, and you ask a question that, okay, what is the price of a 3 BHK? Okay, he quotes some amount. Let's say in context of India, I'm saying, of course, he says 90 lakhs. Basically, he read it from the brochure and he said 90 lakhs because he's 10-year-old, so of course he can read and write. And you're satisfied with the answer, okay? Now, how would we know this person doesn't know anything about the property business?
Ask more detailed questions.
Very good. More detailed question. It is like, let's say I explain some 10 questions in class, okay, or some kind of online session. And in the examination, we ask 7 out of those 10 only. Now, what is the problem with that approach?
Some students might be prepared for those questions that are asked, and some may be well prepared for those that were not asked.
No, but now you have to be very careful.
Are you asking in that case, or I mean in
No,
that sense?
let me elaborate. So let's say there are 10 questions that are discussed in the class, and in the, let's say in an examination, 7 out of those 10 questions are just asked. But all the 10 questions have been seen at least once. So what is the problem here in that kind of assessment scenario?
You are not checking the full knowledge of the...
No,
You know the answer.
Yeah, you already know the answer, right? So the problem is, now what computers can do is, okay, in computers, memory is really cheap, right? So what, rather than solving for everything, what if, like in this residential case, 1 BHK, 2 BHK, 3 BHK, penthouse, all the prices, output prices are written anyways here, okay? And if the questions come from any of these, computer can just do a simple lookup. This could be your dictionary. So how would you know the computer has actually learned it or just stored it somewhere? Because computer, again, the memory is very cheap. So it is easier just to store things and just to keep outputting the same stuff again and again. So how would you know? How would you know there is a 10-year-old who can just learn and memorize things, not learn, sorry, just memorize stuff? Or are you talking to an actual dealer who knows this business, who has dealt, who has really learned the business, and he understands most things about property dealing? How would you know? If the given data is same, the accuracy of his 10-year-old and him's is exactly the same. As unless we ask some question which is not available in the training data set or that has not been shown to you yet. But because you understand the distribution, you can answer that as well. So what we are saying is, let's say we have to draw some stuff here. So that's why. Let's say we plot it properly. Now, where it is. All right. So the whole idea of machine learning is about predictions. Okay, guys. Okay. Now let's say this kind of curve makes the best fit here. Now this might not be correct, but we are trying to go. Okay. Now the point is, if in future someone asks me that what would be the output here? So if I exactly know the representation, maybe I can trace it, and based on this equation, I can tell, okay, this would be the value of y, right? But if all the questions are coming from right here, it is rather than learning, because learning can be like a costly process for computer, I can just record all the information with all the x, okay, which has been shown to me. And I can just spew it back, right? That would be a good technique, right? There is no learning here. It is very easy then. I will just record all the information, because again, memory is very cheap. And I will just repeat it back. There is literally no mistake. So the problem is there needs to be some unseen data which you have not shown it through the training, and which you want to explore, want to gain or understand in the testing part. Okay. So you need to have some unseen data. Let me represent them with a different icon like this star. Let's say all these stars are the unseen data. So this data has not been shown to them at any point. So if they can get the answer right for stars as well, it means they have learned the system or the representation correctly. Did you get this idea what is happening here?
Yes.
Hello? You can ask me if anything is not clear.
No, it's clear.
Okay. So with the representation, sorry, I should do this. So the idea is like this, guys. Okay. Now there could be various learning algorithms. Right now we are taking linear regression, but this is what you are looking is could be common for some other algorithm. So you randomly initialize a hypothesis. Let's say a linear hypothesis here. Okay. And based on the learning algorithm, you keep tinkering it. So you keep changing the hypothesis with the help of training data. And I will show you how to do it. Now at some point, the tinkering is complete, means you have estimated or approximated. Actually, the better word is approximated. You have approximated the theta value. All one sec. So we have approximated theta, okay, all the theta values in that equation. Now the idea is if I put the test data in, the estimated price should be more or less closer, or the output should be as close as to the real values. Okay. So the purpose of hypothesis is to map the feature x to y, set of xi to y. So basically it means you are creating a function of f of x, okay, theta I xi, okay, and basically it can be represented as y.